Hello, yeah, in this video, I want to show you how to compute the bootstrap estimates of mean, standard deviation, median, skewness, and kurtosis. So basically, descriptive statistics of a probability distribution using R. Okay. So first, we want to install required or necessary packages if not already installed. So you can use if parentheses exclamation require of boot. So what this and then install dot packages double quote boot. So this line of code will check if the boot package is installed. If it is installed, then just go to next step. If it's not, it's going to install the boot package. Okay, so here, let's run this and run the other one is the moments. Okay, and we load the library boot in the moments. We can set a random seed. Okay, so we're going to use the F distribution as an example. Okay, so we set a random seed, get a sample size of 100. Degree freedom 1 is 5, degree freedom 2 is 10, and we draw a random sample from this F distribution. Sample size 100, degree freedom 1 is 5, degree freedom 2 is 10. Okay. And now we can write them, write code to compute mean, standard deviation, median, skewness, and kurtosis separately, but we can also bundle them together. So we write this function called the bootstats. So it's you're writing the data and then you have indices. Okay, so you get a sample. You kind of select the indices from the data. So this is actually a bootstrap sample, and then you combine the mean, standard deviation, median, skewness, kurtosis together, and then you're going to return this. Okay, so it will be all these descriptive statistics combined and calculated and returned. Okay. Now let's do the bootstrap. Set random seed, and we want to say, oh, let's do 1,000 bootstrap samples. So you can do that, and then you can use the boot function, the syntax data equal to x. That's the original data sample. And statistics is you use that boot underscore stat function we wrote. And the R, that's the number of bootstrap sample, is number of boot. Okay, so pretty simple syntax. And the computation is very fast. And then you can extract the bootstrap estimates. Basically, it's the mean of the bootstrap statistics. Okay, so you can say apply boot out at t, and the second that's applied for the columns and calculate all the means. Okay, and this will, or you can name all these means as mean, standard deviation, median, skewness, and kurtosis, and then you can print them out. So this will be the bootstrap mean estimates of all these statistics. Okay. We can also go further to calculate bootstrap confidence intervals for each statistic. So we can use a function called boot.ci, which is also a function in the boot library. And the syntax is pretty simple. We can say boot.ci boot underscore out, and we say index equal to 1. So remember we bundled all these 5 statistics together. So 1 is mean, 2 is SD, standard deviation. And you can see the mean, it gave you the bootstrap confidence interval, give you the level is 95% confidence interval, give you a normal approximation bootstrap sample, and also give you a basic bootstrap sample. and also give you the percentile bootstrap sample and also give you the BCA bootstrap sample. So it automatically calculates 4 different types of bootstrap sample. And also there is a warning message tell you the bootstrap variance needed for the studentized intervals. So this is the studentized interval is not generated because the we did not really provide the estimate for the bootstrap variances. Okay, so you can do the same for the SD and the median, the skewness, and the kurtosis. Okay, so the calculations are relatively straightforward. So let's recap the key point here. First, we are using F distribution as the underlying probability distribution we do resampling with. You can use any probability distribution to repeat the same calculations here. And we use the moment package provides skewness and kurtosis functions. Okay, so basically mean, standard deviation, median, these are in the base R, but skewness and kurtosis, we need the moment packages. Okay, and we use the boot package for the resampling and estimation of the statistics. The output the R code computes bootstrap means for each statistic and can also provide confidence intervals. Okay. And here we have a couple of parameters you can actually tweak. You can change the n, the sample size, degree of freedoms, the number of bootstrap samples as needed for your specific analysis. And of course, you can change the underlying probability distribution. So the R codes presented here is flexible to accommodate very broad range of probability distributions, okay, and different parameters you can play with. Okay, so this is an R tutorial showing how to compute bootstrap estimates, including point estimates and confidence intervals for basic descriptive statistics, mean, median, standard deviation, skewness, and kurtosis. Thanks for watching. Yeah, please like the video, click the notification button, and also subscribe to our learning channel. Thank you for your support.